Welcome to the Explainer. Okay, I want you to close your eyes for just a second and imagine being offered the ultimate historic opportunity. You've been selected to be one of the very first human beings to set foot on Mars. I mean, you would become a literal living legend. Your name would be written in the history books right alongside Yuri Gagarin and Neil Armstrong. So, would you accept a one-way ticket to the Red Planet? Think about the absolute fame. They'd name schools, roads, entire buildings after you. You'd be one of the most recognized human beings to ever exist. It sounds like the most spectacular adventure imaginable, right? The ultimate what-if scenario. But, well, there is a massive catch. If you take this journey, based on our current technological limits, you are almost certainly never coming back. It's a one-way trip. Okay, let's really dive into this. The real plot twist here actually isn't just that you won't come back to Earth. It's this number. 4. Despite your legendary pioneer status, your life on Mars will last a maximum of exactly 4 years. That is the absolute limit of human survival outside of our world right now. And look, this 4-year expiration date, it isn't just some pessimistic guess. It is the definitive conclusion of a major scientific study. Back in 2021, a specialized scientific team led by the University of California was formed specifically to analyze the radiation threat to astronauts on a Mars mission. After 2 years of incredibly rigorous research, their findings were published in the journal Space Weather in 2023. And let me tell you, the data they uncovered, it was anything but bright for humanity's spacefaring dreams. The terrifying math they uncovered basically boils down to this. Here on Earth, we are protected. But out there in deep space, an astronaut absorbs an entire 30-year career's worth of radiation in just 4 short years. Just think about that for a second. 30 years of cumulative, lifetime radiation exposure compressed into just 48 months. So the absolutely crucial point is what actually happens when that clock runs out. Once you hit that 4-year limit, the radiation fundamentally ruins your DNA. It begins to systematically break down your cellular structure. At that point, cancer isn't just a risk you might take. It becomes an unstoppable certainty. And no current technology can extend this timeline. Without Earth's protective atmosphere and magnetosphere, 4 years is the absolute maximum a human body can endure. Now, I know exactly what you're thinking, because it's the most logical question, right? Can't we just build thicker armor? Can't we just wrap the spaceship in layers and layers of thick lead or aluminum to block all that deadly radiation? Well, the research team thought the exact same thing, but they quickly ran into a bizarre and, quite frankly, deadly problem. To understand why thicker armor actually fails, we need to look at the 2 major threats in deep space. First, you have solar winds. These are basically bursts from our sun. They're relatively short in duration and lower in energy, though, prolonged exposure will certainly still cause severe DNA damage. But the real nightmare? That's cosmic radiation. These are constant, heavy, high-speed particles shooting continuously through the cold vacuum of space. And this builds into an incredibly bizarre, deadly scenario that I like to call the microwaved chicken paradox. See, when you use incredibly thick armor, yes, it initially stops the cosmic radiation. But as those heavy, high-speed particles constantly smash into the thick metal month after month, the armor itself becomes radioactive. It literally starts emitting secondary radiation inside the ship. So your thick, protective walls essentially turn into an oven, roasting the astronauts trapped inside like a microwave chicken. Adding more metal actually makes the radiation inside drastically worse. No way around it. To prevent this horrific scenario, the experts calculated the absolute mathematical limit for spacecraft armor. And that magic number is 30. You can only have 30 grams per square centimeter of radiation shielding. If you add even a fraction more than that, the secondary radiation effect takes over and the armor starts cooking you. So, with thick armor entirely off the table, the team proposed a truly wild workaround. They suggest timing the journey during the solar maximum. This is the period when our sun is at its absolute most active and violent. I know, it sounds crazy to fly during intense solar winds, but here's the genius part. Those powerful solar winds actually act as a localized shield, physically pushing away the much deadlier cosmic radiation. You are literally using one space hazard to protect yourself from an even worse one. Kind of brilliant, right? But let's just say you survived the journey and successfully touched down on Mars. Are you safe? Nope. Because Mars is completely naked compared to Earth. See, Earth has a thick atmosphere and an active, swirling liquid core that generates a massive magnetosphere. That's our invisible shield. Mars, unfortunately, has a pitifully weak atmosphere and a totally dead core. It has virtually no magnetosphere at all. Stepping onto the surface of Mars means you're still right in the crosshairs of outer space radiation. Because of this, you have to completely forget the beautiful sci-fi dream of building grand, sprawling glass domes on the open Martian plains. If you build on an open plain, you're going to be constantly bombarded by deadly rays. To survive, you have to hide. You'll literally be living like a mole. Colonies will have to be built deep inside Martian canyons or far down in subterranean caves. You will almost never see the surface. And just when you think the radiation is the worst part, well, we have to talk about the gravity problem. Mars only possesses 38% of Earth's gravity. It sounds fun at first, until you realize what that actually does to your body. Living in 38% gravity isn't some fun, bouncy playground over the long term. It's a biological nightmare. If you spend years in this environment, your body fundamentally breaks down. You'll experience rapid muscle atrophy. Your bones will lose their density and become incredibly fragile. And eventually, your entire circulatory system will simply begin to fail because it wasn't designed to pump blood in such low gravity. The environment itself literally melts your strength away. Now, combine all of this. I really want you to think about the severe psychological toll this takes. You're going to spend 99% of your short 4-year lifespan trapped entirely indoors. You'll be confined to cramped, coffin-like underground tunnels. There is zero fresh air, no blue sky, no windows. How long can a human mind endure that level of ultimate claustrophobia before completely snapping? At this point, the most obvious question is, well, why stay, right? If it's this miserable and deadly, why not just do a quick, prestigious 6-month tour on Mars, pack up your bags, and fly back to Earth? The answer to that lies in the harsh reality of orbital mechanics. Earth and Mars aren't stationary. They're orbiting the sun at very different speeds. The perfect alignment for a spacecraft to travel efficiently between the two planets only happens every 26 months. That means if you land on Mars today, a rescue ship realistically cannot even reach you for over 2 years. By the time that transit window opens and they actually get to you, that 4-year maximum survival clock has practically run out. The wait alone will kill you. But let's say you want to try anyway. You brought enough fuel to get to Mars, but you didn't bring enough to get back. It's just way too heavy. So your only hypothetical way back is to manufacture your own rocket fuel. The absolute second you land, you have to locate massive underground ice deposits. Then you have to set up an industrial plant to chemically separate that water into hydrogen and oxygen. Finally, you have to carefully store and burn that hydrogen using the oxygen as an oxidizer. You literally have to build a highly explosive chemical refinery on an alien world just to have a chance at a return ticket. Section 2. Sci-fi solutions for surviving the unsurvivable. Since traditional engineering is clearly failing us here, researchers are proposing incredibly radical, almost science fiction-level solutions to defeat these unsurvivable problems. I mean, if humanity insists on colonizing Mars long-term, we have to get creative. The first theoretical fix is to abandon traditional metal armor entirely. Instead, scientists suggest generating a massive artificial magnetic field around the spaceship itself. Essentially, we'd build a mechanical magnetosphere to deflect cosmic rays, mirroring exactly what the Earth does naturally. It's absolutely brilliant in theory, but currently, we just don't have the technology to make it a practical reality for a spacecraft. But the second solution, oh man, the second solution is where things get truly mind-bending. Have you ever heard of the tardigrade, also known as the water bear? These are microscopic, virtually indestructible animals. They can be exposed to the actual vacuum of space, hit with deadly cosmic radiation that would utterly melt human DNA, and they just shrug it off. They simply do not care. So, some of the boldest geneticists on the planet have looked at the tardigrade, along with certain radiation-resistant fungi and bacteria, and proposed something unthinkable: genetic engineering. Yep, they want to steal the radiation-resistant genes from these microscopic creatures and literally splice them into human DNA. To survive the Martian wasteland, we wouldn't just change the spaceship, we would fundamentally change the human being. But let's be real here, those incredible sci-fi solutions are still decades, maybe centuries away from actually happening. And that brings us right back to the harsh truth of the near future. The very first pioneers who launch to Mars will be stepping into an environment they simply cannot conquer. They will achieve total immortality in human history, for sure, but the ultimate price is that their journey will end with their bodies becoming a permanent part of the Martian dirt. We've explored the radiation, the microwave chicken paradox, the terrifying isolation of underground caves, and the total biological collapse of low gravity. You now know the complete, horrifying truth of what really awaits our first Martian explorers. So I'll leave you with this one final thought. Knowing everything you know now, if the space agency called you today, would you still accept the mission?